This is the Edexcel higher tier, paper 1 from May 2023. Question 1, we have work out 8.46 divided by 0.15. So if I write this as a fraction, 8.46 over 0.15, we can see that we can change this and get rid of the decimals. So whatever you do to the top, as long as you do the same to the bottom, the fraction stays the same. So the same thing works with division. So if I times the top by 100 and the bottom by 100, I can change it into 846 divided by 15. So the same amount of 15s going to 846 as the number of 0.15s going to 8.46. So we can use the whole numbers. So we're dividing by 15. I'm going to write down the 15 times table just because it might help. You don't have to, but it's useful for these division questions. So that's up to 10. And then we'll just do a short division. How many 15s go into 8? That's 0 and 8 left over. How many 15s go into 84? That's 5, which makes 75. And we're at 75, so we've got 9 left over. How many 15s go into 96? That's 6, with 6 left over. So 6, we've got 6 left over, so let's add a 0.0 and 6 left over. How many 15s go into 60? That's 4. We've got our answer, it's 56.4. So 56.4 is the answer. Question 2. Work out 7 3/8 minus 2 1/2. Give your answer as a mixed number. So what we'll do here is change them into top-heavy, improper fractions before we do the calculation. So 7 whole ones is 7 times 8, which is 56. So it's 56/8 and 3/8. 56 and 3 make 59. So we've got 59/8. And 2 whole ones is 2 times 2, 4 halves, plus another half, 5 halves. So 7 3/8 we can rewrite as 59/8. And 2 1/2 is the same as 5 halves. Now we're going to take them away. To add or subtract fractions, we need the denominators to be the same. So I'm going to make them the same. The easiest way to do that is to times top and bottom of my second fraction by 4. And then they'll both be 8ths. So I've got 59/8 minus 28ths. 59 minus 20 is 39. So I've got 39/8. That's the answer, but it's not a mixed number. So how many whole ones do we have? How many 8s go into 39? 4 8s make 32. So that's 4. And we're at 32, so we've got 7 more. 4 7/8. Question 3. A cube has a total surface area of 150 centimeters squared. Work out the volume of the cube. So the total surface area is the area of all the surfaces added together. A cube has 6 surfaces, 6 faces, and they are all squares. 6 square surfaces. So we can work out the area of each one by dividing by 6. How many, or what times 6 makes 150? That's 25. So the area of each face is 25 centimeters squared. We can work out the length by square rooting 25. So what number times itself equals 25? That's 5. So each length is 5 centimeters. And the volume of a cube is length times width times depth, or just the area of the front times how far back it goes. So 5 times 5 times 5, 125. And we measure volume in cubes, centimeters cubed. Question 4. The table shows information about the daily rainfall in a town for 60 days. We could draw a frequency polygon for the information. Frequency polygon is the midpoint against frequency. So the middle of 0 and 5 is 2.5, 2.5. So it's 2.5 against 8. 7.5 against 24. 12.5, 13. 17.5, 11. And 22.5, 4. And then we just join them up with a ruler. So join the points up with a ruler. And that is our frequency polygon. Question 5. We've got a set of numbers, 1 to 10. Our set A is the odd numbers, and B is square numbers. So in the middle, the intersection, are going to be the odd square numbers. So 1 squared is 1. And then 2 squared is even. 3 squared is 9. The other square numbers is just 2 squared, which is 4. Then the other odd numbers, we've got 3. We've got 5. And we've got 7. And then on the outside, the numbers that aren't odd or square are 2, 6, 8, and 10. So we should have all of our numbers in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is our Venn diagram complete. A number is chosen at random from the universal set. Find the probability that the number is in the set not B. So this B prime, B with an apostrophe, means not in B. So how many of the numbers are not in B? That's, well, 3 are in it, so 7 are not in it out of the 10 numbers in total. So 3 tenths it is in B, 7 tenths not B. Question 6. The scatter graph shows information about the ages and weights of some babies. Describe the relationship between the age and the weight of the babies. So we can see it goes up as the age increases, the weight increases. So you could write as the age increases, the weight increases, or we could simply write it's a positive correlation. Positive correlation. Another baby has a weight of 5.8 kilograms. Use the scatter graph. Using the scatter graph, find an estimate for the age of this baby. So whenever we're using a scatter graph, we need to draw a line of best fit. So it's a line that goes through the points, minimizing the distance between the points and the line. So roughly the same number of points on both sides, and showing the relationship, going up with the relationship. And then we just use it. So 5.8 kilograms is up here. And then we come down to the line and we read off from our graph. There'll be a range of acceptable answers for this question. We've got something like 3.7 or 3.8. I'll put 3.8, but there'll be a range of answers and just read off whatever it says on your one. Question 7. The price of a holiday increases by 20%. This 20% increase adds £240 to the price of the holiday. Work out the price of the holiday before the increase. So 20% is 240. So 20% of the price is equal to 240. So if we want to work out the whole price, we want 100%. So if we take 5 20%, we get the whole price. So 5 240s. So 240 times 10 is 2,400. Half of that, 1,200. So if we find 20% of 1,200, it will be £240. Question 8. The diagram shows a solid cylinder on a horizontal floor. The cylinder has a volume of 1,200, a height of 40. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure. So pressure is force over area. We've got the force, which is 90. So we need the area. So we need to know the area of the cylinder that's in contact with the floor. So this area of the base. We're not given it, but we are given the height and the volume. And volume is the area of the cross section times the height. So 1,200 is the area of the cross section times 40. So we can find the area by doing 1,200 divided by 40. We can simplify that calculation, dividing top and bottom by 10. So we've got 120 over 4. 12 over 4 is 3. So 120 over 4 is 30. So we know the area and we know the force. So we can just put them into the equation. Pressure equals force divided by area. 90 over 30. 30 goes into 93 times. So the pressure is 3 newtons per centimetre squared. Question 9. Use these graphs to solve the simultaneous equations. So we've got 2 simultaneous equations. They're drawn for us on the graphs. When we have simultaneous equations on a graph, the answer is the point of intersection. So at this point here, the x and the y are equal for both of the lines. So that's the answer to the simultaneous equations, the point of intersection. And 2 simultaneous equations, the solution is always where the 2 lines meet. So it's at 6, -2. X is 6, y is -2. Question 10. Here is a pentagon. Angles in a pentagon. So angles in a triangle is 180. A quadrilateral, 360. A pentagon is 540. It goes up by 180 every time. So 3 sides, 180. 4 sides, 360. 5 sides, 540. And we are told angle AED, this one here, is 4 times ABC. So if this one's x, this one is 4x. So we can work out the size of the missing angles because we know they sum to 540. So we've got 5x, 4x and 1x is 5x. We've got 120, 135 and 110. So that is 365. So 5x plus 365 must equal 540. So let's take 365 away from both sides. So 540 take away 365. So 10 take away 5 is 5, 13 take away 6 is 7, 4 take away 3 is 1. That's 175. 5x's are 175. And then we can work out what 1x is by doing 175 divided by 5. I'm not going to do the long way. I'm just going to say 35. If I double it, double 175, I get 350. And then that would be 10x. 10x is 350. So x must be 35. We want AED. So we don't want to know this angle here. We want to know this one here, which is 4 times 35. 2 35s are 70. So 4 35s are 140. Question 11. We're simplifying. So write this in the form ax to the power b, y to the power c, where a, b, and c are integers. So we're just going to simplify the top line, simplify the bottom line, and then divide them. So the top line we're squaring. So 6x to the power 5y cubed squared. So we times it by itself. So we're going to square each of them individually. 6 squared, 36. X to the power 5 squared. X to the power 5 times itself is x to the power of 10. And y cubed times itself is y to the power of 6. And the bottom line, 3 4s are 12. X squared times another x is x cubed. And y to the power of 7 times y to the power of negative 3. When we multiply, we add the powers. So 7 and negative 3 make 4. And now we can divide. Top divided by bottom. 36 over 12 is 3. X to the power of 10 divided by x cubed. When we divide indices, we take away the powers. So 10 take away 3 is 7. And 6 take away 4 is 2. So 3 x to the power of 7 y squared. Question 12. Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. And we need to find the probability that Martha will lose at least one game. So there's different ways of doing this. We can do win-lose, lose-win, and lose-lose. They're all the ways she could lose at least one and add them together. Or we can do 1 minus the probability that she wins both. And that's a bit quicker. So let's do win-win, which is when we go across the branches, we times. 5 times 2 is 10. 8 times 9 is 72. So we've got 10 over 72. 1 minus 10 over 72 is going to be 62 out of 72. Y is directly proportional to x. That's a relationship. Y equals something times x. Y is 24 when x is 1.5. So we can find out what that k is. That's just a number. So k, divide both sides by 1.5 to get k by itself. 24 divided by 1.5. If we double top and bottom, it's 48 over 3. So it's 16. So k is 16. So the relationship between y and x is y equals 16 times x. Y will always be 16 lots of x. So when x is 5, what is y? 16 times 5, which is 80. Question 14. Write 1/16 in the form 4 to the power of n, where n is an integer. So 16 is the same as 4 squared. So it's 1 over 4 squared. And when we flip a fraction, we've got the reciprocal, we use a negative power. So 1 over 4 squared is the same as 4 to the power of negative 2. 4 to the power of negative 2. So 4 to the power of negative 2 is 1/16. And work out the value of 8 to the power of 5/3 minus 9 to the power of 3 over 2. So when we have a fractional indice, the bottom one is a root. So for the 8, we're going to cube root it and then do that answer to the power of 5. So if we cube root the 8, we get 2. So it's the same as 8 to the power of 5 over 3. It's the same as 2 to the power of 5. And the same with the 9. If we square root it, it's a 2, so it's a square root. This one was a 3, so it was a cube root. The square root of 9 is 3. So 9 to the power of 3 over 2 is the same as 3 cubed. 2 to the power of 5 is 2 times 2, times 2 times 2 times 2, which is 32. 3 cubed is 3 times 3 times 3, which is 27. So we've got 32, take away 27, and that's 5. Question 15. The equation of line L1 is y equals 2x minus 5. The equation of line L2 is 6y plus kx minus 12 equals 0. L1 is perpendicular to L2. Find the value of k. So when we have two perpendicular lines, one's gradient is a negative reciprocal of the other one's gradient. So for L1, we can see the gradient, it's in the form y equals mx plus c. So m is the gradient, and the gradient is 2. So the gradient for L2 must be the negative reciprocal of 2. So it's minus the negative and reciprocal flipped over minus a half. The two gradients always multiply to give us a negative 1 when they are perpendicular. So the gradient of L2 must be minus a half. Let's put it into the form y equals mx plus c. So I will get y by itself, make y the subject of the formula. So I'm going to take kx away from both sides and add 12 to both sides. And then divide everything by 6. Divide each term by 6, which gives me y equals minus a sixth kx plus 2. So when we divide by a number, make sure we divide every term by it. Same as when we times by a number, we times every term by that number. And we can see that gradient is minus 1/6 k, and we know that must be equal to minus a half. So let's make them both positive, times both sides by negative 1, and then times both sides by 6, which you'll get k by itself. 6 halves make 3. So k is 3. Question 16. Here is a sphere. The surface area of a sphere is 4 pi r squared. 3/8 of the surface area of the sphere is 75 pi centimeters squared. Find the diameter of the sphere. Give your answer in this form. So 3/8 of, so times, the surface area of the sphere, 4 pi r squared, is equal to 75 pi. 3/8 of 4, so that's the same as 1.5, so 3 4s are 12. 12 over 8 is the same as 1.5. So 3/8 of 4 is 1.5, or 3 over 2. So let's write that as 3 over 2 pi r squared equals 75 pi. Now I'm going to divide both sides by pi so I can get rid of it, which leaves me with 3 over 2 r squared equals 75. Times both sides by 2. Divide both sides by 3, and we get r squared is equal to 50. So the radius must be square root. The radius must be square root 50. And I can simplify square root 50. I can change it into root 2 times root 25. And root 25 is just 5. So that's the same as 5 lots of root 2. So the radius is 5 root 2s. The diameter is 2 lots of the radius. So it must be 10 square root 2. And we had to give our answer in the form a root b, where a is an integer, a whole number, and b is a prime number, and 2 is a prime number. So 10 root 2. Question 17. Make x the subject of the formula. So get x by itself. So the first thing we want to do is get rid of the fraction. So to get rid of a division, we do the opposite, which is timesing. So times both sides by 5x plus 3. So y times 5x plus 3 equals 4 times 2x minus 7. Let's expand the brackets. So 5xy plus 3y equals 8x minus 28. We want x to be the subject. So we want all the x's on the same side. The problem here is we've got 2 lots of x's. So we're going to get them to the same side, and then we're going to factorize out the x. I'm going to move the x's over to the right side, just because I prefer my other terms to be positive. It wouldn't be wrong if you did it the other way. You'll just end up with an equivalent answer. So I'm going to move my x's to the right. So I'm going to plus 28 to both sides. And I'm going to take away 5xy from both sides. So that will give me 3y plus 28 equals 8x minus 5xy. I've now got the x's on the same side and everything else on the other side. That's what I want. Now I'm going to factorize out the x. So take x out. That leaves 8 minus 5y. And then I can get x by itself by dividing both sides by 8 minus 5y. So x is 3y plus 28 over 8 minus 5y. If you did it the other way around, it wouldn't be wrong. You'll just have negative 3y minus 28, and then you'll have 5y minus 8 on the bottom. Question 18. 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of £4 of 480p. So 7c and 5t. C being the cost of a kilogram of carrots, t being the cost of a kilogram of tomatoes. is equal to 480. And then the cost of 1 kilogram of carrots, the ratio of the cost of 1 kilogram of carrots to 1 kilogram of tomatoes is 5 to 9. So the ratio of carrots to tomatoes, a kilogram of carrots to a kilogram of tomatoes, is 5 to 9. So how can we make this into a second equation so we can have simultaneous equations? The quick way is to just cross them over and say 9c equals 5t. You could equally say that c is 5/9 of t and t is 9/5 of c. Any of those equations would be absolutely fine. So we need to solve them now. We've got two simultaneous equations to solve. You could get them in the form you're used to, have 9c minus 5t equals 0, and solve them as simultaneous equations that way. That would look like this: 9c minus 5t equals 0. And then we could solve the simultaneous equations by adding them together. That works absolutely fine. Or we could have substituted in. We could have said 5t is 9c, so we can substitute in for 5t 9c, and we'd get exactly the same thing. So with either way, we end up with 16c equals 480. Let's get c by itself. Divide both sides by 16. How many 16s make 480? 3 16s make 48. 16, 32, 48. So 30 16s make 480. So carrots cost 30p per kilogram. And then we can use any of these formulas. So 9c, we can substitute into this one, or the top one up here. Any of them to substitute in the 30p. So let's do the top one. 7 times 30 is 210. 210 plus 5t equals 480. Take 210 away from both sides. That leaves 270. And divide by 5. So double it. And then divide by 10. So tomatoes cost 54p per kilogram. Question 19. The menu in a restaurant has starters, mains, and desserts. 5 starters, 12 mains, and X desserts. There are 420 different ways to choose. Work out the value of X. So 5 starters, 12 mains, and X desserts, and there must be 420 ways of picking. 5 12s is 60, so 60x equals 420. So 6x is 42, dividing both sides by 10. And then that is 7. 6 times 7 is 42. So x must be 7. Question 20. For x is greater than 0, the functions f and g are such that f of x is 3x plus 4. G of x is root x plus 2 all over 5. Find the inverse function for g. So the opposite function to g at the moment, I'll do this 2 ways. So with a diagram at the moment, we put in x, we square root, then we plus 2, then we divide by 5, and we get out our output. If we do this backwards, we would times by 5, so do the opposite. Times by 5, so 5x. The opposite of plussing 2 is minus 2. The opposite of square rooting is squaring. So it's 5x minus 2 squared. If we use the formula, we would say y equals square root x plus 2 over 5. Again, we're undoing the formula, so times by 5, take away the 2, and square. So we've got 5x. When we switch x and y around, so in the inverse function, we switch them around, 5x minus 2 squared. And part B, solve gf of x equals 3. So we're putting f into g, and it's equal to 3. So put f into g. So where we had the x, we're going to change it into 3x plus 4. F into g, and it's equal to 3. So let's solve times by 5. Get rid of the division by doing a multiplication. Take away the 2. Square both sides. 13 squared is 169. Then take away the 4. 169 take away 4 is 165. And then divide by 3, which is 55. Question 21. AB and D are points on a circle with center O. CDE is a tangent at D. Work out the sides of angle ADC, A to D to C, this one here. Write down any circle theorems that you use. So we can use the circle theorem that says the angle at the center is twice the angle at the circumference. So they're both coming from these 2 points in the same segment. So the one at the center is twice the one at the circumference. Half of 64 is 32. An angle at center is twice angle at circumference. Then we can use angles in a triangle. So 32 and 51 make 83. So we need 97 more. And then opposite angles are equal. We don't actually need to write them down because they're not circle theorems. But it's good practice to make a note of them. 97, and then we've got angles in a triangle again. So 97 and 64, how many more to 180? So 3 more onto 97 to make 100. 16 more onto 64 to make 80. So 16 and 3 are 19. So we've got 19 degrees in here. Again, angles in a triangle. And we know a tangent meets a radius at a right angle. So this is a right angle here, 90-degree angle. So x is 90, take away 19, which means it must be 71 degrees. Question 22. A, B, C, D, E, G, F, A, B, C, D, E, F, G, H is a cuboid. A to F is 6.8 centimeters. F to C, this one here, is 13.6 centimeters. Work out the size of the angle between FC and the plane ABCD. So that'll be this kind of shape. So we've got a triangle, a right angle triangle, and we need to work out this angle. So we're going to use SOHCAHTOA, and we've got the opposite, and we've got the hypotenuse. So we're using sine. So sine x equals opposite over hypotenuse, which is 6.8 over 13.6. It's a non-calculator paper, and luckily 6.8 over 13.6 is exactly 1/2. So sine of what angle is a half? It is 30 degrees. Sine 30 is a half. So it is 30 degrees. Question 23. Write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form a root 3 plus b over c, where a, b, and c are integers. So we've got 2 steps to this. We need to rationalize the denominator, and we need to add or take away the fractions. I'm not sure it matters what order we do it in. You could do it in either order. Yeah, either way around. So let's rationalize the denominators first. So when we have 2 terms on the bottom, we use the opposite sign. So 4 plus root 3, we want to times by 4 minus root 3 times by 4 plus root 3. We're using the difference of 2 squares to get rid of the third. So times top and bottom by 4 plus root 3, and the third on the bottom will go. And for our second fraction, it's a simple one. We just times top and bottom by square root 3. And that will get rid of the third. Let's expand now. 3 root 3 times 4 will be 12 root 3. 3 root 3 times another root 3. The 2 root 3's times together to make a 3. So we've got 3 3's, which is 9. On the bottom, 4 4's make 16. We've got plus 4 root 3 minus 4 root 3. That's going to cancel out and get rid of the third. And a negative root 3 times a positive root 3 is minus 3. And we've got 2 root 3 over 3. So simplifying, 16 minus 3 is 13. The 2 middle bits cancel. Now we can add our fractions. We want the denominators to be the same, so we can add them or take them away. So if we times top and bottom of our first fraction by 3 and our second fraction by 13, we will get 36 root 3 plus 27 over 39 minus 26 root 3 over 39. And then we can just take them away. So 36 root 3, take away 26 root 3 is 10 root 3 plus 27 over 39. And question 24, find the set of possible values of x for which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. You must show all your working. So we've got to solve both of these quadratic inequalities. The first one is the difference of 2 squares. So we can factorize it. 2x plus 5 times 2x minus 5. So x is equal, what makes the first bracket 0? Minus 2.5. Makes the second bracket 0 plus 2.5. So minus 2.5 and 2.5 are the points where it's equal to 0. We want to know where it's less than 0. So if we sketch the graph, it's a quadratic graph that crosses at minus 2.5 and 2.5. Where is it less than 0? It's less than 0 is below the x-axis. That's this part here. That's below the x-axis. So it is between 2.5 and minus 2.5. So that is what makes the first one 0. For the second one, again, we just need to solve the quadratic. Let's make it positive. Let's move everything over to the right side. So 3x squared plus 5x minus 12. So it's where 3x squared plus 5x minus 12 is less than 0. Let's factorize. I'll do a times c, 3 12s, or 3 negative 12s is 36, or negative 36. That could be 1 36, 2 18s, 3 12s, 4 9s, or 6 6s. How can I make a 5? It's going to have to be 4 9s. So it's 3x squared plus 9x, take away 4x. So I'm rewriting the 5x as 9x minus 4x. I'm not changing anything else at this stage. So instead of 5x, I've written 9x minus 4x. I've gone back a step, so when we expand brackets, we get these 4 terms. Then you simplify the middle one. I've gone back to the 4 terms, which makes it easier to factorize. So what can I take out the first two? They've both got 3x in them. And then 3x times something is 3x squared. That's x. 3x times something is 9x. That's 3. Something times x is minus 4x. That's minus 4. And minus 4 times 3 is minus 12. So x, what makes the first bracket 0? 4 thirds. The second bracket, negative 3. So again, what does this look like on the graph? It is another quadratic, crosses at negative 3 and 4 thirds. And we want to know where it's less than 0. So again, less than 0 is underneath the graph. So the x values between negative 3 and 4 thirds. So we want to know the set of values for which both of these are true. So what does x have to be for both of these to be true? So it can't be between negative 3 and negative 2.5 because this one isn't true. But it can be bigger than negative 2.5, and it can go all the way up to 4 thirds. It can't go past 4 thirds because this one stops being true. Even though this one's true, all the way up to 2.5, we just want to know where they're both true. So that is the answer.